as part of this broad scope of information that we've been trying to get across as part of the forum, again, we've been speaking about materials, testing standards. We've seen what happens on Tuesday when a vehicle has a sticky bomb and what happens along the way. Hopefully next year as an incentive to come back next year, we are hoping, bless you, we're hoping that we will be able to repeat the blast testing event with the Geneva Police, but this time with a larger volume of explosive material, which would be interesting to see how then the vehicles do perform. So then the part we've been speaking about brakes today and the driving side, and so I think to really bring it all together is our presentation on tyres. And if you think about it, as I was told many years ago, the only thing that's connecting you and the road are the tyres. And if the tyres are not up to standard, fit for purpose, then the brakes might be terrific, the suspension might be terrific, the armouring might be terrific, but your mobility performance will not be terrific. So we're very pleased today to have Theo Verbrugen, got that very good, from JRZ, who will really, it's a wonderful presentation about tyres from the technical aspects of the importance and their makeup, and therefore the influence on a vehicle's mobility and survivability in that regard. So please welcome Theo. The stage is yours.
Thank you very much. A small introduction of myself. I'm Theo Verbrugen, 60 years old and 35 years in the racing parts and tire development industry. Working at JRZ Suspension Engineering now for 11 years. JRZ main business is suspension systems for high-end racing cars, pickup trucks, armored cars and off-road racing buggies. JRZ Suspension Engineering is a Dutch-based company with more than 50 years of experience in the highest level in racing and armored car suspension systems due to our founder Jan Zuidijk. About 9 years ago, I developed, in cooperation with Maxis, a special armored car tire from scratch, specially designed for the needs of heavy-duty armored vehicles like the Toyota Land Cruiser up to 7,000 kilo, and of course many more platforms. What I want to present to you today is how tires are made, a simple short video. Then tire construction, it's about the carcass, the bead seat area, the sidewall and the tread. Then the differences in tread, the highway terrain, the all-terrain and the mud terrain and their benefits. Then what sidewall codes mean, how tire conditions impact vehicle mobility and performance, and especially the tire pressure. And then at the end, the summary, the benefits when using the correct tire for the specific armor vehicle use and weight. Now a short video how tires are made.
It all starts with the preparation of the basic components. The rubber is made up of 4 types of materials: rubber or elastomer, reinforcing fillers, plasticizers, and chemical additives. The rubber or elastomer is either natural, that is produced from the cultivation of the rubber tree, or synthetic, that is made from oil. These raw materials, conditioned in bales, are shredded to facilitate the preparation of the rubber compound. Carbon black and silica reinforcing fillers are added to these elastomers, giving the rubber its wear resistance. Various plasticizers, such as oils or resins, help to make the compounds uniform and facilitate extrusion. Other ingredients come in powder or granule form. These are chemical additives, and their dosage amount is an extremely complex operation on an industrial scale. Formulation must be permanently accurate and regular. These additives include sulfur, and we will see later on that it plays an essential role in obtaining the mechanical properties of the rubber compound. All these components are carefully mixed until perfectly uniform. The way the various components are mixed and cured is as important for the performance of the tyre as are the choice and quantities of the materials. The amount of each compound is carefully measured to meet requirements in terms of flexibility, resistance, grip, etc. The rubber compound then obtained is identified to ensure full traceability and then conditioned for subsequent transformation. The tyre is also made up of long metal cables and textile cords made of Armoured, nylon, etc. to withstand the significant stresses to which it is subjected, the first being inflation. Once these various components have been prepared, they will be transformed into a multitude of elements. Flat products, shaped bead fillers, metal or textile wires, as well as bead wires. Production then starts on the drum, a rotating cylinder with edges that can be brought together and the center that can be inflated. We shall see why. The first element to be laid on the drum is a thin, airtight sheet of synthetic rubber which acts as an inner tube. It is then topped with a fabric ply encased in rubber. These cords form the radial carcass of the tyre. Extruded rubber bead fillers are installed on either side to accommodate the bead wires, which are inextensible metal hoops used to clamp the tyre firmly against the wheel rim. The carcass ply is folded up over the bead wire to secure it in place. Then it is the turn of the other parts to be added, including the sidewalls made of tough yet flexible rubber, which are designed to protect the carcass from side impact. The center of the drum is inflated to bring the two edges together and give the tyre nearly its final shape. Two plies are added to the tyre crown. They are reinforced with metal wires which are placed crosswise to the carcass ply in order to form a solid network of triangles. The assembly of these components to tolerances within 1/10 of a millimeter will give the tyre its performance in terms of safety, longevity, energy efficiency and comfort. A fret or fabric ply is then laid down, forming a belt that encircles the tyre in the direction of rotation. At high speed, it will prevent deformation due to centrifugal force. Lastly, an extruded profile is laid down. This is the tread, the part in contact with the road surface. The first stage of the tyre's construction is now complete. It can now be transported to the curing mold. A bladder filled with pressurized hot fluid in the center of the mold forces the still malleable substance to flow into all the cavities of the tread pattern engraved inside the mold. The heat of the fluid around the mold starts the curing process. The increase in temperature causes the sulfur contained in the rubber compound to bond with the rubber molecules. This is what we call vulcanization. The rubber is then transformed from a plastic to an elastic state. When ejected from the mold and after cooling, the tyre has taken on its final shape and properties.
So, as you can see, it's not an easy process to make a tyre with many things to handle. Then, to give a little bit more information about how to make a special armored car tyre. The bead area is very important for an armored car, because there your steering reaction comes from the bead area. So what we did, for example, for our special armored car tyre, we increased the strength of the bead wire. The bead filler, we made it higher up and from a very hard compound, which significantly improves the handling of the car. And especially the heavier the car, the better handling you get with this. Then up. One moment, where is that? It stopped working. By the word carcass, there is the flex point of a tire. A flex point is very important because all the radial and actual here, all the radial and actual force which come into a tire by accelerating, braking and turning, a lot of heat, just like with the brakes, must be released somewhere in the tire. And that's normally, it's on this point here. So the flex area is very important. If you make it too short, the tire will heat up there, will boil and will explode. So we made it from a bigger surface here, and also the positive point is that the tires still remain very comfortable to drive, even with the higher pressures you put into the tire. And by the bell section here, we put 2 extra layers to get the perfect footprint of the tire, even by high loads of the tire. Then the differences between the highway terrain, the all-terrain and the mud terrain tire pattern. The highway terrain, it's a tire primarily for paved roads, highways and urban driving. The characteristics are similar to a standard passenger car. Tire featuring a smooth tread pattern for maximum comfort and low noise. The pros are fuel efficient, quiet on pavement, and provide a comfortable ride. The cons: limited off-road capability and may not perform well under mud and gravel. Then the all-terrain tire. It's a mixed for daily driving and light to moderate off-road, including dirt and gravel roads. Characteristics: a compromise between highway terrain and mud terrain, featuring a more aggressive tread pattern than the highway terrain, but less extreme than the mud terrain. The pros: versatile for varied conditions, offering a good balance between on-road comfort and off-road capability. The cons: slightly less comfort and fuel efficient than the highway terrain tire, and less compatible than the MT in extreme conditions. Then the mud terrain tire. This is made for extreme off-road use, particularly in heavy mud, rocks and rugged terrain. The characteristics: large, widely spread tread blocks and deep channels designed to eject mud and rock for maximum grip. The pros: of course, unmatched traction in extreme off-road situations, and the cons: noisy and less comfortable on pavement, with reduced on-road traction and short tread life. So in summary, the HT is for on-road focus, the AT balance between on-road and off-road, and the MT is off-road extreme focused. Then, what does sidewall codes mean? In this case, you see on the left side the tire size. The P is for the passenger car. It also can start with LT, which is a light truck. Then the first size, the 225, means 225 millimeters is the tread width in millimeters. And the 65 means 65% of the 225 millimeters is the sidewall height. Then the R means radial construction, and the 17 is the wheel or the rim diameter. Then the 102H, the 102 is the load index. I come later with a list, and H is the speed index. Then the DOT code, which is very important, I think, for armored cars. Normally, the last 4 digits, in this case 2320, means the production date of the tire. In this case, week 23 from 2020. And then the UTQG, I come back on later. The UTQG is Uniform Tire Quality Grading. Normally this is used in America. This is not used a lot in Europe. This is a qualification system that measures the lifespan, temperature resistance and traction of the tire. In this case, 640 means the tread wear rating is a comparison number that indicates how long it takes for a tire tread to wear down. A higher rating means a longer lifespan. In this time it's 6 times 4 more than a 100% tested tire, or what they name in OEM is the zero tire. And AA, traction, means this stands for a high traction rating, which means excellent grip, especially on wet surfaces. Then there are some other marks on the tire, like mud and snow, which indicates this tire is possible to use in mud and snow conditions. In Europe, we have now a new tread marks with 3-peak mountain snowflake. So in Europe now, in many countries, you must have the 3-peak mountain snowflake in winter conditions. And then the max load and max pressure in this tire, in this case, the maximum load on this tire is 1874 lbs, and the maximum pressure is in the tire is 41 psi. Then there is another marking in lately on cars, which is the run flat or EMT marking. Markings like ZPS, zero pressure system, or the EMT, extended mobility tire, signify that the tire has reinforced sidewalls and can be used for a short distance after a puncture. Then the load index charge, you can look it up on Google and everywhere. So in the case of the tire we just showed, it was 102, which means 850 kilo the tire can be loaded to that weight. Then the speed rating, in this tire it was H, so H means the tire can be used up to 130 miles an hour or 210 kilometers an hour. Then tire types for different regulations, and this is especially in Europe. You have the C1 type tire, this is for passenger cars. The C2 type tire, light commercial vehicles, till load index 121 or 1450 kilo. And then the C3 type, it's for heavy vehicle tires, loaded above 1450 kilo, intended for vehicles above 350 kilo. All three these types have specific tire regulations in rolling resistance, fuel consumption, grip on wet road conditions, noise and dB. And for the armored car tires, most vehicles are above 3.5 ton. So the C3 is the regulations with the highest specification. So it's at this moment it's hardly not possible for tire manufacturers to make a tire which is for the Toyota Land Cruiser approved, but with the rolling resistance and everything they expect. So at this time it's very, very difficult to make a tire for our market. Then the labeling which are on the tires in Europe especially. So the label says the fuel consumption here is C, that's the rolling resistance of the tire. Then the grip in wet conditions, in this time is D. Then the noise of the tire, and here it shows the 3-peak mountain snowflake, that the tire can be used under winter conditions. Then the most important thing I think of my presentation is how tire conditions impact vehicle mobility and performance, and especially tire pressure. On the left side you see a tire which is underinflated. So when the tire is underinflated, the tire will be hollow on the surface, and you have only the wear on the outside of the tire. When the tire is overinflated, the tire will be round and will only be touch the surface in the middle, and there will be the wear. What brings that to the tire? So on the left side, the properly inflated one with a perfect footprint. This means correct traction, optimum handling, and optimum tire life. If you underinflate the tire, you see it's a little bit hollow. You have only on the outsides, you have the grip, which brings you poor handling, poor economics, and rapid tire wear on the edges. On the right side, you see the tire which is overinflated, only grip on the center of the tire, which brings you also poor grip, inefficient traction, and rapid tire wear in the center. So the summary, the benefits when using the right tire for the specific armor, vehicle, use and weight. You have to start with measuring the front and the rear axle weight to know which load index is needed. Then you have to determine the maximum speed of the vehicle. We'll see. So corresponding, you need to choose the right speed index. Then use of the vehicle to determine the type of pattern. So is it the HT or the MT? And then most times the AT line is the best, especially in sand and dunes and gravel conditions, and then for the lifetime. Even in dunes, better than the MT tire. Because the MT tire easily digs in the sand dunes and you get stuck. They make much more noise, easier to penetrate, and get tire leaks. And in wet clay or snow conditions, the better choice always is a snow chain for the best result. Put the correct tire pressure on the front and on the rear tire. Can be different. These can be different because of different weights for the front and rear axle. If possible, I always recommend AT over MT. For example, in Paris-Dakar, where the road surface is 100% different every day, and during the day, all the teams use AT type pattern, and they do this for the best results also. And the last one, please do not spare money on quality tires, as they will pay themselves back on the long run during the lifespan. When all points what we discussed are covered in the perfect way, you will get the maximum grip, shorter braking distance, lower fuel consumptions, less tire wear, better steering reaction, and a safer ride under all circumstances. That was my presentation. Thank you very much.
Look, thank you for that. And I have to say the video was, I think, the highlight from my side. Yeah. Not understanding how tyres are made. You go down to Bob Jane T-Mart, if such exists. These guys will know Bob Jane T-Mart, and just buy a tyre along the way. So a couple of questions or issues maybe you can discuss a bit too. One is recommendations for tyre maintenance, for inspecting tyres and maintaining tyre health, so to speak, in a civilian armoured vehicle. So that's one issue. And the other one, we've seen, and we have with one particular client, that the tyre seemed to strip off and it just sort of disintegrated as they were driving, without seeing the photos, of course, but maybe you can talk to some of the issues of tyre failure and the causes and what might actually happen to the tyre when it fails when you're driving.
The failure of the tyre in 99% comes of the low tyre pressure or too high tyre pressure. When you treat a tyre in the payload they are made for, and you put the right tyre pressure inside, there will be hardly no issues. Of course, there can be a stone inside and which go into the carcass, and there you get a separation of the carcass. It starts there, and then you get that the tyre will or damage only by a leak, or that the thread is coming off. So this kind of things can happen, which you cannot prevent, because sometimes a stone or a piece stuck in, and because the thread go down, it push in the carcass and it's done. So yeah, I mean, but mostly it's the lower temperature, sorry, the low pressure, which make the high temperature in the tire, and then because of the high temperatures, the glue between the different lines gets separated, and then the tire will explode or come apart. And the first question was
for drivers and fleet managers in the field is then the inspection of the tires. What should they be looking for in order to assess the health of the tire and if that tire is fit for mission?
I mean, what they just said also, I mean, the best way is by every trip you do, check, and especially for armored cars, check the tire pressure, always. And it can be by very low temperatures. It's even more important than by if you go in Dubai for 45 to 50 degrees, because there the tire pressure will only increase, and a little bit increase. Normally they put it on the low side. So and then to change the tire, normally between 2 and 3 years. It's when you have a very heavy car, it's better to change the tire after 2 or 3 years when it's not, the tread is not on the marks. Yeah.
Yes, indeed. Oh, not anybody sick.
Hi, Theo, thanks again. So coming back to your comment about the temperatures.
Yes.
Does it really a significant gap in the required pressure when it comes, I don't know, if you're taking it to 45 degrees in one location and another vehicle being sent to 10 degrees or to even to 0 degrees, the required inflation pressure is
Still the same.
It's still the same.
Yes, correct.
Okay.
Because in the cold temperature, the air inside is colder, so you still need to put the pressure in the tire to keep the tire the perfect shape, because that's important. If the tire is too low in pressure, the tire will in the middle like this, and in the side you saw the roundings, and in the roundings there comes a temperature build up, and when you drive too long for high speed, the temperature is so high, then you get the tire failure. So even when you are, let's say in Norway or Sweden, you have, let's say, 5 bar, the same 5 bar you need when you put it in Dubai.
Okay.
Yes. Yeah.
Indeed. Just one moment here, I'll give you.
I just want to ask about emergency repairs, roadside repairs. You get a deflation, but you stop in time to save the tire from disintegration.
Mm-hmm.
What do you recommend to carry on board as a temporary repair on the road, apart from having to jack the car and replace the tire with the spare?
To be honest, for armored cars, I don't recommend a simple solution, because the weight and everything is so high. Normally also with trucks with a higher weight, they take the tire off the rim, they put from inside they put something in with a glue, and then they cut it off. Not like passenger car tire, you put in a rubber hose with some glue. So with the armored car tire, and also if you see the steel wires, so you can even not go through the steel wires so easily. So it cannot be done with, especially with our car tire what we made, and I think most tires in that weight range have the same problems.
Okay, and what about a mousse that you inject through the air nozzle?
That can be done, but normally they use a certain kind of fat for the run flat, and the fat with the glue will not mix together, so it has no point to do that.
Ah, I see. So there's like a grease, a lubricant to reduce the friction between the run flat and the...
Correct, yes, and that will not correspond with the special glue what you normally can use.
Okay, that's interesting. Thank you.
Yeah.
Another question that I've got is, is the life of a tyre, and when someone would buy a tyre, and certainly when trying to do logistics supports to remote locations, or even not so remote locations, what a number of the procurement agencies or fleet service agencies will do is they'll buy a stack of tyres and they'll put it on the floor, waiting for a mission to call, I need 4 tyres, 8 tyres, whatever the case may be. Can you comment on the life of a tyre from its production date until it becomes too old that you should not then put it onto a vehicle? It must have some sort of time frame, and then saying, well,
Normally that's 6 years normally.
6 years.
Yes.
Sitting on the shelf. All
But
right.
when the tire is on the car and the car stands for a very long time, the steel belt
Right.
will get sharp edges because of standing still, and can break there. So when the tire is on the car, we recommend to change every 2 to 3 years the tire. When the tire is in the store and it's dark and everything, you can use it up to 6 years.
Up to 6 years.
Yeah.
All right. Good.
On exposure to sunlight in some extreme climates, how does that degrade the tires? Or is there now a chemical compound in the tire that...
The tires are made to get used to this. So all the tire manufacturers, they produce for Middle East and Far East, and so the compound is made to absorb that. It's no problem.
Okay, thank you.
Yeah.
Well, then I do have another
There's
question. Oh, yes, we'll come. One sec. Is in some cases there will be missions that won't use vehicles often, won't drive too many kilometres. You'll find that a vehicle will then sit in a carport or a garage and just sit there. And it could be for days, weeks, sometimes even months, depending on. And so you've got, therefore, all that weight sitting on the same spot of the tyre. Can you comment about that sort of, I suppose, bald spots or whatever you might call it, and how should an organisation deal with long-term storage of vehicles in that regard?
The right tire pressure, it starts with that, because then you get less that the steel thread will be bent. But for the rest, you feel normally when the tire was long on one place, the first kilometers you feel a little bit vibration in the car, but that will go away. But if you do this, so that's why we say when a tire is not used many times, after 2 years, we say, okay, change the tire to prevent that you get stuck on the way. But normally you feel the first kilometer, you feel a little bit vibration, and then the steel belt will go round again, and then it's done. So there is flexibility inside, but not for many, many, many years.
I've been told that the air in the standard air pumps at gas stations has too much moisture in it, and that ruins the tire, and that the best results for long-lasting tires is to fill them with nitrogen. Is this any truth to that?
Nitrogen, the only positive thing is that the tire pressure will increase less by heating up the tire. So when you put normal air inside, for example, when you increase the tire from 20 degrees to 80 degrees, then there will be 0.2 or 0.3 bar extra. But with nitrogen, it will be only 20% of that. So that's the only plus point of nitrogen. It will not increase too much after temperature increase.
The question is how many kilometers I can do on the set of tires. Let's say ideal conditions, because the cars are driving different areas, but it's 10,000.
No, it's way more, but it depends what you say on the temperature. Is it only on paved roads? Is it off-road also? So how does the driver drive? I mean, when he goes very fast and roundabouts and things like that. So it's very hard to say, but between 40 and 80,000 kilometers is normally no problem.
Okay, super. Thank you.
So that's interesting. And if I can ask, actually, Justin, if I can put you on the spot, you've got a wide, a large fleet dealing in the heat and different road conditions of Iraq, and you've got a lot of experience on managing the fleets there. Have you any sort of thoughts or comments on the tyre, the longevity, the maintenance, and any observations from your fleet there?
Yeah, thanks, Rob. Pretty much as Theo said, tyre pressures absolutely the main point to manage. You know, and we get our teams check them every day before they go out on task. Make sure they're cold when they check them. Don't check them at the end of the day when the tyres are warm, and setting the right pressure. So doing a weight calculation and then going on the different websites, you know, the ETI, RTA websites to look at load weights for the specific pressures for those vehicles and just ensure that that's correct. Vehicle geometry, massive issue with tyre wear. A lot of the vehicles are up armoured, well, all the vehicles are up armoured, different suspension systems, potentially different ride heights, put the geometry out, and in an armoured vehicle with incorrect geometry, the tyres last 1,000 kilometres. So the toe, the camber, so it all changes. You know, if the vehicle's slightly higher than the OEM vehicle, it puts the toe out, it puts the camber out. And what we found is that's critical to tyre wear.
Correct.
You'd have the answer. Well done. All right. Any other last questions? No. All right, fine. All right. So, look, Theo, thank you so much.
No problem.
I used to own, it's a quick personal story. Many years ago, I owned an MGB sports car, very nice sports car. And the wheel was attached to the axle and had actually a locking, like a bolt that would rotate opposite so that it would self-lock. And this was a terrific development by the MG Motor Company. It was in Great Britain at the time. Unfortunately, this was a second-hand car or fifth-hand car that I bought, and they actually swapped the tyres around. So instead of the locking nut locking, it actually over time unlocked. And I was driving down one particular road in Melbourne, and then I feel this bump, and the whole left side goes down, and there is my tyre bouncing on the road in front of me. And it's a rather scary thought. So whether it's the wheels themselves or the tyres, I learned the lesson. There you go, lessons learned. The critical that they're actually attached to the to the vehicle and that they do their job. So look, thank you so much. Appreciate it. A small gift to say thank you so much for participating. Please say thank you to Theo.